Right, now, for this particular question, question 13, well, we did vectors before. As I said, you need to know some basic facts about vectors, like, how to tell if two vectors are parallel, how to know if two vectors are perpendicular, how to compute vectors, how to find the angle between those two vectors. Now, something different for this time, because in the past, it was always two-dimensional. You only see two numbers inside the vector. But this time, we got the third number. So, so what we have here is a three-dimensional vector. X direction for the first number, Y direction for the second number, and Z direction for the third number. But the way we do it is exactly the same. We just basically stretch it for a little bit more. Okay, for example, for part A, it says, please go ahead, find out the vector V, and vector V is composed of 3s minus 2t. Now, what we do, okay, so we say, all right, so 3s minus 2t. So the 3 in front of s means that you will multiply the numbers inside the s by 3. So the 4 becomes 12. 3 becomes 9. And negative 2 becomes negative 6. Now, what I see the most, well, what I saw most often from the last test is that when there's a minus, people start to freak out. Now, the way I handle this is I'm going to keep the minus over there, and that means I'm going to multiply the 2 into the t, just the 2, not negative 2, just the 2. So negative 1 becomes negative 2, and 2 becomes 4, and 5 becomes 10. Okay? And then you understand that it is a subtraction. Therefore, you just tell your mind that, okay, you have 12 minus negative 2, which is 12 plus 2, 14. 9 minus 4, 5. Negative 6 minus 10. Done. Okay? Just like what you did with two-dimensional vectors, we just go one extra slot. Okay? So that's basically what it is. And make sure your mind is very composed, very calm. You can listen to what you're thinking. You know what you're doing for each single step. Yes? Well, that's what I'm saying. If you want to keep the minus, I would like to keep the minus. So that means only the 2 multiplies into the t. Now, if you want to multiply the negative 2 into the t, then this sign becomes a plus. So you can do it either way, but just make sure that you know which way you're doing. You cannot do both. It should be the same. Because if you multiply the negative 2 into the t, then this should be this should become a plus. So it's like you plus negative 2t. That's the way you think about it, if you want to multiply the negative 2 into the t vector. Okay, good question. All right, now what about dot product then? Well, dot product means we will multiply the components, and then we will add them all, right? So, well, we used to have just the x and y, they multiply to each other, or they multiply like x times x and y times y, we add them all together. But now we have a little z, the third slot. Just do that, and make sure you use parentheses. Parentheses are your good friends to keep you organized and stay on the right track. However, what I saw on the last test was this. 4 times negative 1, well, you know it's negative 4, so that's not too big of a problem. It's very strange that the problem comes in when you have 3 and 2 right next to each other. People started writing 5, where it should be 6. Now, my guess is that because you see the plus right around it, so your brain is like, are we adding? So I might do crazy things. And then people look at -2 and 5. They somehow wrote down 7 or -7 or 3. Like that's what happens if you don't discipline your mind enough. So therefore you get a -8. Okay. So again, nothing too fancy. It's just one extra slot. So you just extend your work process a little bit more. And then we say, all right, could you please find the angle between S and T? Now it's a 3-dimensional vector, but still 2 vectors, and we could find out the angle. Well, the way we found out the angle, it's same equation. What's the equation for the angle one? We say it's cosine theta is equal to what? The dot product over the magnitude. What is the relationship between the magnitudes? Are they adding or are they multiplying? They're multiplying. But for some reason, I saw a lot of plus signs on the last test. Don't know why. Okay, they're multiplying each other. Well, magnitude. How do you find the magnitude of a 3-dimensional vector? Okay. Well, the way you do it, it's really the same way that you would do the Pythagorean theorem. It's just that now we do one more digit. So for vector S, so you have 4 square plus 3 square plus -2 square. And that gives you, I'm going to write them all down because my mind it's not going to handle these numbers very well. So you have a total of square root of 29. Okay. So that's the magnitude of S. And we do the same thing for the magnitude of T, which would be -1 square plus 2 square plus 5 square. Again, just like what you do with your regular 2-dimensional vector with Pythagorean theorem. It's just that now we have a little extended vector. So we have to take care of it. Okay, so we got a square root of 30. So now we can just put in all the values that we found. So -8, square root of 29, square root of 30. It's going to cosine theta. Okay. So then it's all calculated work. So if you put into your calculator, okay, you should find a value of 105.737 degrees. Okay. Now I also saw something from the test last time. Now people who it's very consistent. People who somehow put the plus sign in the denominator, they are the ones who get a value of the fraction that's way too big, and then when they put into the calculator, it becomes undefined. Well, if you know something's undefined, then you should really go ahead and take a look at what you have done wrong, because there's an angle. There is an angle. Okay, but if you say I forgot the equation, then I can't really help you on that one. Okay, yeah, but that's the one that you need to make sure. So yes, okay, you need to know how to handle this 3-dimensional vector. But the work, it's just like the 2-dimensional vector with one extra step, okay, because of the Z component. Okay.